So Justin asked me Weber sign 9.5, number 3. So that's what I'm going to do. So determine the convergence or divergence of a series. Like this is an alternating test. Okay, alternate test has what condition you have to meet. There's 2 conditions you have to meet. One first condition is what? The limit goes to what? 0. What's the second condition? So your a sub n plus 1 has to be less than what? A sub n. So you have to do 2 conditions. Because the theorem says the condition has to meet. Then you can use alternate test. Okay, so looking at this, I know for sure I'm going to use alternating test. So alternating give you what? Negative, positive terms. Term changes each term. Okay, like you can starting with looking at this, you start with the negative 1, right? So I'm gonna look at this, and then what am I gonna do? It says if I do limit, so I'm gonna check the first condition. Check the first condition. What's your first condition? Limit goes to what? Limit of what? Kx, Kn, 0 as what? It gets what? Infinity. All right, so I'm gonna do it. Then let's do it then. What number do you wanna try? So we're gonna try some numbers. So n equal to, say, starting with n1. I won't have a lot of numbers to know. Like remember, I want my n goes to infinity. So what number do you want to try? Do you want to increment by like 10 and try 100? What do you think? I'm talking to you, Justin, since this is your problem. Does that look good, okay to you? So this means what? I'm going to try any of them, all the way to 100. I don't want to calculate every one of them. I'm only going to want to see what? Every 10th one. So 1, and then what? 11, so on and so forth. Okay, so that's what I want to do. Then let's look at this. K dot n. Oh, did I not define this one? Okay. Okay, I didn't run it, right? I wrote it, but I didn't run it. You have to do enter. So let me look at this. Let's see. How does it go? It is definitely getting what? It is definitely getting smaller. Can you tell? One is going down what? 461, 5.5, 4.50 is getting smaller. It's getting closer to 0. No, negative 1 is over here. And it's getting what? Closer to what? 0. Wyatt, tell me again. What is your question? No, look at your number line. Here's your number line. Wyatt, watch it. Here's a 0. Here's a negative 1. Here's a negative 0.5. Do you see it? So negative say 0.45 would be right where? Right here. So it's getting what? Getting close to 0. We want it to be 0. We don't want negative number. We want to get it to be what? Close to 0. So it is getting close to 0. Oh, by the way, you have to do absolute value. So you want your limit to go to 0 when you do the absolute value. So I guess I don't have to use negative in the front, right? So I can do, because when you do alternating series, you don't have to worry about the negative sign. So you can just use 1. Okay, so you have this positive number. Okay, the negative 1 to the n power only alternating your signs. That's the only thing different. Okay, so as you can see, it's getting what? Closer to 0. So you don't really like this. You're gonna say, you know what? I don't like this number. I want to see more. What can I do? Can I go all the way to 1,000? Okay, do you want to be still 10 or you want to increment a little more? How about 20? All right, I can definitely see it's getting what? Definitely getting smaller. Right, remember the first number is 1. That's getting smaller, smaller, smaller. So I can assume, yes, it will go to what? 0. So I'm going to say yes. I'm going to assume this. Okay, what's the second condition then? Okay. So what can you say? The series goes to 0 when n gets larger. Therefore, it meets the first condition. I would love to show it graphically, right? The graph is the one that really you can tell. So let's graph this. And then what? See the behavior. Okay. Using plot Lee.js. Okay, I'm gonna run so I can see graphically, numerically, and I'm gonna see numerically probably again what? Graphically. Okay. So as you can see, what happened? It's starting at 1. Okay, Justin, do you see it? Starting at 1, what happened? It's getting what? Smaller. So it's approaching where? Approaching to where? 0. Now we gotta do what? Check the second condition. What's the second condition? A sub what? A sub n plus 1 has to be less than what? A sub n. So we got the k. Now I'm gonna find what? Can I say just a k2? Do you mind if I put k2? Okay, so I'm gonna call it, this is my, okay, I want you to remember. So my k2 is my a sub 2. Okay, I'm calling it k2 as my what? A sub n plus 1. And k is what? A sub n. So this is a k. So what do I need to do? Whenever I see n, what do I need to do? Change into what? N plus 1. That's right. Okay, so be sure you put your parentheses around right. Otherwise, your answer is not correct, right? So put the parentheses around it. This parenthesis is not really necessary. Okay, are you with me? So now that's my k plus, that's my n plus 1. All right, so how can I compare? Let's compare them. Compare 2 series. So I'm going to make a what? Matrix, right? So I'm going to do k dot n. That's my first one. The other one is what? K2 dot n. Let's compare them. Number 3, 9.5. Okay, let's look at the numerically. So this is a sub n. This is what? A sub n plus 1. So you want a sub n plus 1 is smaller than a sub n. So which one is bigger? A sub n is bigger than what? A sub n plus 1. Let's give everything always a sub n is what? Larger than a sub n plus 1. So I did it numerically. Now let's do what? Let's do graphically. Okay. So we're going to compare two series graphically. So I'm going to scatter n, comma, k dot n, title, compare two series, line width 3, and label. That is your A sub n, right? And then you're going to do scatter, bang. I'm going to do now k2 dot n, line width also 3, label. That is what? A sub n plus 1. All right, let's graph. Okay. There are just so many of them. It's kind of hard to tell. They're very lookalike. But important is very first one. Look at this very first one. You can see the difference. So A sub n is much bigger than what? A sub n plus 1. How do you know? Just look at your cursor. It says at 1, A sub n plus 1's y value is 0.87. What is the other one? 1. So this is a bigger y value than this one. So graphically and numerically, you found the answer. So now you can say, what can you say? Again, definitely numerically and graphically, we can conclude A sub n plus 1 is less than A sub n. Therefore, the given series is what? Converges by what? Alternate series test, okay? .61 number. 1. Okay. Okay, 1, what do you have to do? You just need to graph this. Okay. Look, you tell me what I need to do. Okay. You want to cut A of n, okay. Yours is the 4/5, okay. Mine is 7/8. I would the 4/5 to the what? N power, okay. Okay. Okay, match the series with the graph of each sequence of partial sum. Okay, so I need to find another function, right? Okay, so you want to call it, what you want to call that function for? Okay, SA n is equal to sum, and then what? 1 to n, right? So you're gonna say this is your sum function. So I need to write down what that means. Let's go up and say this is what? Right, partial sum function. And this is what I'm defining my problem. Now what do? JS. Okay. So we're going to graph. Okay. So scatter. Point right here. You're the 1 to 10. Okay. Okay. This is the only one. Yeah, I can do. So if you want, I can do just a sum. Right, we do. So you can just match it. Right. So you answered the first one, right? That's exactly. Okay, everybody to get together so we can do it together. 9.7. 9.7, number 8. So this is your last problem for this. Okay, so I'll come to 9.8, 9.7. Let me come down to 9.7 right here. So problem 8. So what do I need to do here? Let's see. It says determine the value of x for which the function can be replaced by the Taylor polynomial if the error cannot exceed 0.001. So it looks like to me, I need to find the differences between what? Each one of them, 1 and 2, and then 2 and 3, 3 and 4, and make sure what? That's less than which number? 0. So it has to be less than 0.001, then I can stop. Okay? They already gave you, so you don't even have to find the polynomial. So this is a polynomial they gave you. So looking at this polynomial, what can you say? What's the polynomial degree? 3, because I see a power as a what? 3. So it looks like to me they already gave me a polynomial degree 3. But remember, this is a sine function. Remember, sine function, all the odd numbers is what? 0. When you plug in 0 to your x. Okay, so this case, this, in other words, this time all the cosine gets what? 0 when you plug in what? Pi. Okay, class, this is another thing you need to know. I think yesterday Lydia asked me, look at this problem. Okay, look at this problem. You know this is your polynomial, right? A polynomial degree 4. And then you're wondering yourself, how come it doesn't have any odd numbers? Like, where is there something to the 1 power? Where's something to the 3 power? Right? And then you said, we don't have those odd numbers because, wow. So this function is cosine. So derivative is what? Sine. And first, a second derivative would be what? Cosine. It's alternating. Are you with me, class? But I don't see any signs. That tells me I am a center at which number? Center at where? 0. Because sine function looks like this. Okay, center at 0, sine is 0. So I know it's a center at x equal to 0. That's why sine 0 gets to 0. Anytime you see a sine, you get what? 0. Okay, so what happened with the cosine then? Okay, looking at this, what can you say? I can see this is a center at where? Must be pi or something, right? Because I don't see any cosine terms. Look at this. Okay, f is sine x. What's f prime of x? Cosine x. What's f double prime of x? Negative sine of x. F triple prime of x would be what? Negative cosine of x. F4 power would be what? Sine of x. Are you with me? Okay. So what can I say? I don't see any of what? I see a third power. So class, in other words, I have a what? Actually, I see this. And I see this. So in other words, it's still centered where? 0. Are you with me? That means I have f terms. Okay, look at the sign. So in other words, I don't have this. That which indicates what? It's a center at where? X equal to 0. So that's why you don't have that and you don't have this. And then you're not going to have which one? That. All right, so which means I can take one more of them, just like yesterday. which is cosine x. All right, to find this to be what? Find the what? Remainder. Could this remainder give you what? This remainder give you 0. So I can use both of them, either 4 or 5, like yesterday, if you want. All right. So looking at this now. So if I use 4 right here, if I use 4, so I'm just going to this one. I use this remainder of 3. I need to look at what? One more of them, right? One more derivative. So I look at the sine z. Z has this between which two number? Oh, that's the one that you're looking for right now? Okay, that's the number that you're looking for. So sine 3 over 4 factorial x to the 4. Now you're going to say again, the sine. What's the maximum number you can have for the sine? What's the sine as maximum number? Then you can have y value as a 1, right? So you're going to say, okay, anytime this has the less than equal to just because x to the 4 is the same as what? 1 times x to the 4. So I'm going to replace sine as just a 1 and saying the sine cannot be more than 1. It's less than equal to 1. Are you following me? So you have 1 times x to the 4. And then you're going to say under the what? You're going to say I want this number to be what? Less than 0.0001. Okay? And then you're going to say, okay, how do I find it? First thing first, just do the regular what? Algebra by dividing by what? 4 factorials. Then you have x to the 4 is less than 0.001 divided by 4 factorial. Okay, are you following me? Divine? So you put this in your calculator, that must be equal to this number. Okay, now what do you do? Remember, this is the 4th root, 4th power. I'm looking for x. So what I need to do what? X is what? Less than equal to 0.024 to the what? 1/4 power, or what? Same thing, 0.024, 1/4 power and the negative. That's what it is. Let me delete it. Okay, here. So with the 9.7, you have to find the derivatives. Yes, you can do your work in a Jupyter notebook for the simple calculation part, but the algebra part you have to do either on your notebook, the paper that I'm going to give you, or you need to do it where? On your Jupyter notebook, like I did here. You see all these things that you have to find. You need to find the derivative, second derivative, and third derivative, and fourth derivative, whatever that you need to. So do you understand how you got this number? Okay. Do you understand why I'm doing this? Okay, class, you have to understand, okay, why am I finding the fourth derivative? Why am I going to the 4th power, the 4th derivative? Why? Because your given problem has a third polynomial. Third polynomial means how do you find your error? You have to go up. Take one more derivative. The 4th derivative, which is this. It's a sine. Remember, it's alternating. Cosine, sine, cosine, sine, cosine, sine. The 4th derivative is a sine again. Then you're going to tell yourself, the sine, I don't know what z value I'm going to use. I don't know. Remember, they didn't give it to me. But what I know is sine cannot be more than 1. So you're going to say it's less than equal to just 1 times of this. I'm replacing the sine with just 1. And then you're going to say, okay, I don't know what x is, but I can do what? Divided by, multiply by what? 4, excuse me. 0.001 times 4 factorial, not divided. Multiply by 4 factorial. Then give you this number. And then now what do you do? Take a 4th root, okay, and then give you this number. So the x has to be between what? Those two numbers. Does it make sense? Okay.